now we have almost everything we need to write TinyBASIC. So let me go over the structure of the interpreter that you will be implementing and the individual steps or the tasks that you will need to do. First of all, let's look at the structure. So the basic interpreter, the basic language, the sort of static source code representation that we will work with is distinguishing between expressions and commands. Most of the interesting things that you will need to write are commands. So commands are the things like printing, reading a value, if in BASIC is a command, and goTo is also a command. We also have some small language of expressions where you can write some Boolean conditions, for example, and the expressions evaluate to values. This part is relatively simple, and it's pretty much the same idea that we had in TinyML. But the commands are the more important and more interesting part here. The whole list of all the commands that you might have in the final version is here. There's a couple of commands for jumping, goTo to a specific line. BASIC had a GOSUB, which I will explain in a second. And there's return, which is part of the GOSUB operation. We will want to have some I/O for clearing the screen, printing, and reading an input from the user into a variable. And then we will want to have conditionals. Conditionals are interesting because they don't have two branches. In BASIC, the conditional is just you have an if, then you have an expression, the condition, and if the expression holds, a specific command is executed. Otherwise, the execution just continues to the next command. We will have assignment where you set the value of a variable, and we will need commands to run and stop the program. The other part, and this is now talking about the dynamic structure, what exists when the program is running, is this state. So state is a record that keeps all the information that BASIC needs to run. When you start programming, we will only have one thing, that will be the program, and that's a list that contains a line number and a command. So that initially the program's state will just be the source code, because we need to have this available when we want to implement something like goTo. Later on, we will add variables. We will want to have some random numbers, so we'll need to keep track of that as well. And GOSUB, which is this operation for subroutines, will need a return stack. But that's a bonus thing that we will be adding later on. And then the other thing we need, sort of the operations that implement the logic, and that's transforming the current state of the program. And the most important thing here will be the run command function that takes the current state, takes a command alongside with the line number to execute, and produces a new state. And then the whole execution of the program will be just a sort of sequence of executions of this run command function. The function needs both the command and the current line, because the typical thing that it does is that it will run the command and then proceed to the next line. So it needs that current line number. And to proceed to the next one, we will write the helper function run the next line, which will look for the next line in our current state, our current source code. So let me show you how this looks in the implementation. I have a very minimal starting point. Your starting point template will have a few more things in it, but I just have the current the value. So the only value we can have is a string, and the only expression I have right now is a constant. And here the constant is any value, so we can create constant strings. And then in my command, I just have print of expressions and then a command to run a program. From the state, as I said, I only have the initial thing, which is program containing the list of lines with the line number, and the command. And to make things easier, we will keep this list of lines sorted. So you can assume they come in the right order. And I am starting by creating an empty program. Now I do need to define everything, and then I can create an empty program. And I've defined lines, which is a list where we say on line 10, there's a command to print constant string hello world. One aspect of F# I want to show you here is typically when you modify the state, we're writing things in a functional way, so we are going to construct a new value of the state. But typically you will only want to change some of the attributes of the state. Here we just have one, so this is not very realistic. But later on, the thing that will be useful is you are able to take the current previous value of the record and say, I want to change one of its properties, the program in this case, to a new value. This will clone the object, keep everything else, and change just this one thing. So now I have a new program state, and I can show you a little bit how the run command function, which is where you will need to do most of the interesting work, how it looks. So this takes a state and a tuple with line and command. Just so that I can show you the type, it will return the state. As I illustrated earlier when talking about tuples, this is a function that takes sort of one argument, that's my state, and another argument, which is a tuple. The reason why I wrote it this way is that the type of this is compatible with the type of things that we are storing here in this list. So that will make a lot of programming easier because, for example, when we want to start the program, we will be able to just say, find the first thing in the program, first element, which is the tuple, and pass it to run command. I will also be using a special convention where I will use -1 to represent this is a command that has no line number. So if I want to later on start this program that I defined here, hello, I can say I want to run the run command, and this came from the outside, doesn't have a line number. And what I need to do now, so in run command, this is where we have to do the interesting thing. We will need to look at the command and decide what to do. So if the command is print of some expression, now because I only have constant strings, I'm going to make this easier for myself and assume this is the string that we want to print. And I'm going to print this string. So this is handling the print case. Now, after we run this command, what we need to do is we need to run the next line. So I'm going to implement this as two recursive functions and run the next line, which I will leave the implementation of this to you, but it will take the state, take the line, and what this will need to do is to find the next line in the source code after the one that we've given that we are given, and fetch that from the source code and pass it again back to run command. For now, I will just return the current state. So we print it, and then in BASIC, we just want to continue to the next line. So we will call run next line. The other thing that we can get is the run command. And so what do we do when we get run? Run means that we want to pick the first line from our program and start running from there. And so to do this, I can do first line, and we will look at the program, and there's a function called list.head, which gives me the first element of the list. I am assuming it is not empty. And so first now is a line number alongside with a command, and this we can directly in the current state pass to the run command function recursively back to itself. And so if I define both of these functions, create my sample program, and then run it, this does indeed print hello world, and then it also returns the current state. We will need to be passing the state around later on because as we, for example, define new variables, we will need to keep track of those. So this is a slightly simplified version of the starting point that I will give you when you are writing your own TinyBASIC implementation. So there's a few more things in BASIC, and there's one interesting aspect of the language that's one of the bonus tasks that you can try to do later on. One interesting feature of BASIC is that aside from GoTo, which we have seen already, there's also GOSUB. And what GOSUB does is that it jumps to some location, but it remembers the line from where you jumped. So you can then use return, and return will jump back to that original location where it was called from. So that's a nice way of making your basic code a little bit less messy and making Edgar Dijkstra a little bit happier about your programs. In printing, there's sort of few more options. What is useful, I mean, we can do poke, and that puts a character to a specific location. You can also do print, and print actually takes a sequence of expressions. So you can sort of print a constant string followed by some variable value. There's also a function called input that lets you read a value into a variable. And that's the most interesting, most important thing that you will be working with. One of the advanced tasks is implementing support for GOSUB. So I want to give you a quick example of how this actually works using the emulator. Let's say that we just want to print hello 3 times. Now, if you wanted to do this explicitly, of course, you can write print hello, print hello, print hello. Let's say we want something more complicated. That will be more lines of code, and we don't want to duplicate that code. If you wanted to do this without GOSUB, you will need to somewhere remember how many times it was called and then implement basically a loop. With GOSUB, we can just sort of 3 times say GOSUB and the number where our code starts. So if we put some printing of hello at line 50, that's our subroutine. And then on line 60, we will say return. We can now write some program that at line 10 says GOSUB 50. At line 20, continues and calls 50 again. And again, for the one more time, we will call the line 50. And once we've done this, we will maybe just jump to 100, where we will say done. So if I now run the program, this prints 3 times hello, and then it prints done. And this is one example where we will need to add something extra to the state, because when you call GOSUB, the system needs to remember that you jumped from the line 10, 20, or 30. So that's sort of one example of how imperative programming makes this state more complicated, and that's also why reasoning about imperative programs becomes more difficult, because there's sort of more stuff in the state. So if you implement the bonus task, you will see that you have to add an extra thing to the state record. So what are the steps of implementing TinyBASIC? The first thing that I will ask you to do is to add support for GOTO and improve the print operation a little bit so that you can write your own infinite loop that prints hello world over and over again. And for this, you just need to add this operation for finding the next line and also finish the evaluator for expressions. Then the next thing we will want to do is implement how this interactive program editing works. So when you write a command that has a line number followed by some command, this actually means not run the command, but modify the program source code. We are not going to be implementing parsers in the Tiny systems, so I'm just going to assume that these things you will kind of have to write them by hand, but we still want to implement the underlying logic of how the program gets mutated. That's the second step. In the third step, and this is something that will let you run a little basic game, we will want to add variables, conditionals, integers, and booleans. A lot of this is just extending the expression evaluator. The interesting thing is that now you have to extend the program state to also store the values of the variables. And once you have this, there's a little interactive game for you that you can play. The next step is adding random and poke. And if you do this, you will be able to run a program that puts the stars on the screen as we did earlier in the emulator. The poke, we're not going to do the exact correct poke as it was in BASIC, because that really is just modifying memory. So we'll just have a little sort of toy poke that lets us put things on screen. And then there's a sort of couple more functions and operators that you need to add to be able to have a little game running in BASIC, including functions for reading input from the user. If you want to do more on BASIC, the bonus task is implementing GOSUB, where you will see that you need to extend the state, and then we can use this to refactor the code that we've written for a game. And the bonus problem for you, the sort of extra additional problem is actually use our basic interpreter, TinyBASIC, to write an AI player for our game, which, according to Wikipedia, is a solved problem. So once you finish the tasks, there are a couple of interesting things that you can sort of learn from this exercise. One is that the basic part, the evaluation of expressions, is exactly the same as TinyML. So this is really a sort of core pattern that appears everywhere. The implementation of the command execution is slightly different, because now we're not just taking the expression, we also need to handle this state, which is more complex as we are adding more advanced features to the system. Hopefully you will get a glimpse of how exactly this interactive editing worked, even though we will not have a parser and we will not have a sort of full interactive experience, but you can write the editing commands in your source code and then run it and see how that worked. So it's not quite an interactive programming environment yet, but the tasks will illustrate the sort of key logic of how a system like this worked.